So we talked about when computing limits that we can just plug in the number to the function if the function is nice enough. Well, what is this concept of nice enough, right? Well, what this is we say that a function is continuous at a certain point or a certain number if we can just take the limit by plugging it into the function. So here's a definition for you. The definition, a function f is continuous at x equals a if the limit as x approaches a of f of x is actually just equal to f of a, right? So you've seen some examples where the limit of the function of as x approaches a might not actually equal the actual value of the function, right? Think, for example, a function that looks something like this, right? A function that looks like that. If this is your function f of x, this is a down here. Well, if this value right here is, say, 1, and this value up here is 2, we would have that f of a is equal to 2, but the limit as x approaches a of f of x is 1, right? So this would be an example of a discontinuous function, or a function which is not continuous. A good intuitive way to think about what a continuous function is that you can draw it without picking up your pen or your pencil, right? So we can be discontinuous in a couple different ways. So ways to be discontinuous. Change the color here. The ways to be discontinuous. So think about what a graph could do that would make you have to pick up your pen. Well, we could have something like we did in this last example here, this last picture. You could have a hole. Right, so you could have something that goes like this. You get a hole, and then the function keeps going. Right? This one here is what we would call a removable discontinuity. Well, removable discontinuity. Right? Because we call it removable because it sort of looks like you can just plug up the hole. Right? Right? There's another type of discontinuity. Maybe something like this. Right? Something where the function jumps. And as you might guess, we call this a jump discontinuity. Right? Because the function jumps up. Right? And last but not least, there's one more way you could run into a discontinuity. And it's what's called an infinite discontinuity. And this just means you have an asymptote, a vertical asymptote. So let's say you have a vertical asymptote here. Think of like the function 1 over x. That's a good example. So you could have a function that looks like that, right? And this one we call an infinite discontinuity. Right? So these are the three different ways in which the graph of a function can force you to pick up your pen. Okay? And these are the three different ways where the actual value of a function could differ from the limit of the function. Right? So having functions that are continuous are great when you're trying to compute limits, because if you know it's continuous, you just plug in the value and you're good to go. So what types of functions are continuous? So what functions are continuous? Well, the following are continuous on their domain. Okay, so these are continuous on their domain. All right? So that means on every piece of the domain the function has, even if it has some asymptotes on the individual pieces that it's continuous on, or sorry, that it's defined on, it'll be continuous there. So 1, we have polynomials. These are always continuous, no matter what. These are continuous everywhere. Right? Rational functions. Right? What are rational functions? These are like a polynomial divided by a polynomial. So these are continuous as long as the denominator is not 0. Okay. What else could we have? We have something a bit more general, which we call algebraic functions. All right. These just mean that they're functions built out of algebraic operations, like adding, subtracting, multiplying, dividing, exponents, so square roots, cube roots, like any kind of powers of x, right? Powers of x, rational functions. So really, algebraic functions include these last two. Right? What else? Well, we also have exponential functions. All right, we'll talk some more about those later, but this is stuff like, 2 to the x, for example. Okay. 5, logarithms. Logarithmic functions are continuous. And again, we'll talk more about these later, but this is stuff like ln of x. Okay? And lastly, trig functions. All of them are sine, cosine, tangent, and the other 3. Right? So it's sort of good to know that we can take these sort of building blocks of continuous functions and sort of stick them all together and make bigger continuous functions.